Hello, and welcome to this code review for my Rescue Animals project from IT 45 Foundation and Application Development course at SNHU. This was developed in Java and soon to be enhanced with full stack capabilities. This application is designed to assist an animal rescue organization in maintaining records of rescue animals, specifically dogs and monkeys. I'll walk you through the code in three main areas: software design and engineering, algorithms and data structures, and databases. I'll also explain how transitioning to full stack implementation with web interface and MongoDB backend will help make this application more accessible and effective. Let's begin with category one, software design and engineering. The Rescue Animals application currently allows users to add animals, view records, and update their reserve status. This functionality is organized across several classes. We have rescue animal, dog, monkey, and driver, which controls the flow of the application and user interactions. Dog, monkey, and rescue animals are responsible for the animal classes, each containing attributes specific to the type of animal. Driver handles the main application and user interactions. There is proper naming conventions were used. Camel case for methods and Pascal case for class names. Now let's break down each file in detail. In terms of modularity, the application is well organized. Each animal type, dog and monkey, is represented in its own class, with shared attributes stored in Rescue Animal class. Rescue Animal class holds universal attributes like name, animal type, gender, age, weight, and so on. And these are common attributes that are used across the other animals. This is done to avoid redundancy in calling out these in each individual class. Dog extends rescue animals, introducing an additional attribute, breed. By using inheritance, dog.java can access all the properties from rescue animal, ensuring reusability. Monkey class also extends rescue animal but adds tail length, height, body length, and species. It also includes constructor with default values for these fields, making it easier to handle cases where the user may not input specific information. The modular setup of distinct classes for each animal improves code organization and maintainability. Additionally, if we want to add animal types in the future, modularity allows us to extend rescue animals with minimal disruption to existing code. This structure is also advantageous for transitioning to full stack application, as we can map these classes directly to MongoDB collections and access them via API endpoints. Currently, driver acts as a main entry point, controlling everything from user interaction to data handling. This setup means that driver has multiple responsibilities, including managing animal lists, processing user input, and handling errors. The file contains a lot of tightly coupled functions. For example, the intake new dog, intake new monkey, and print animals methods have overlapping code input and checking for duplicates. That would be a good portion of this section here, and same thing here. Handling both user interface and backend operations. Driver lacks modularity, making it difficult to maintain and expand as the project grows. A practical solution would be to separate these options into an animal manager class, which would handle specific tasks like creating, updating, and deleting animals. This class would also serve as the backend for web application, with methods that align directly with the API endpoints. Instead of individual intake methods for each method or each animal, a method like intake new animal, and animal manager could handle shared attributes, reducing in redundancy and allowing the front end to interact with a single endpoint for animal creation. Moving responsibilities out of driver will improve readability and reduce coupling. In full stack application, the structure makes it easier to implement an API that the front end can call, separating front end logic from back end operations and creating a more modular, maintainable application. Currently, error handling in driver is minimal. For instance, if the user inputs an invalid command, the program only displays invalid entry without detailed feedback. If the user enters a non-Boolean value where a Boolean value is expected, or if there is an issue with the data formatting, the program can crash or behave unexpectedly. Adding a catch block in critical areas like parsing user input and database interactions would ensure better handling. For example, in the method reserve animal, we could verify that the input is valid and send any message to the front end in a user-friendly format. Adding error handling not only improves application reliability, but it is essential in full stack application or full stack setup, where error messages need to be managed both on the back end and appropriately displayed on the front end. Documentation is limited, especially around complex user input handling. Additionally, some older comments from previous versions remain, which could be confusing, such as these in here and in here. Clear, updated comments would improve reliability and help future developers understand the purpose of each method. Documentation is also critical for full stack application where API routes and front and back end interactions need to be clearly defined. My plan includes modularizing driver by creating animal manager class to handle animal operations, serving as the backend for the web server. I'll be adding error handling to manage user input and improve integration with the front end. I'll improve documentation to maintain clarity for backend methods and API endpoints. Refactoring redundant code to simplify driver and prepare it for full stack functionality. For category 2, algorithms and data structure. The driver file currently uses an array list to store dog and monkey at our objects, enabling CRUD operations or create, read, update, and delete. However, because it relies on looping through the list to search and filter animals, the application becomes less effective as the data grows. The application currently uses array lists for storing dog and monkey objects. While functional, this approach isn't scalable to O for N complexity and data retrieval. While the array lists, well, with an array list, finding a specific animal requires looping through an entire list, which is time consuming as the dataset grows. This linear search can become a performance bottleneck. Switching from arrays list to MongoDB collections would make the data storage more efficient. MongoDB indexes each document by a unique identifier, so retrieval operations are faster, with O for log n complexity. Using MongoDB supports faster data retrievability, scalability, and persistence, aligning with best practices for data storage and larger applications. This change also connects well with full stack design, as MongoDB collections can be accessed and manipulated through API endpoints for web interface. The current code relies on linear searches to filter animals based on criteria such as availability, training status, and service country. For full stack setup, MongoDB would handle these filtering tasks more efficiently. For example, MongoDB can perform direct queries on indexed fields like training status and reserved, minimizing in-app looping. Switching to MongoDB queries reduces the need for looping and complex logic within driver. Instead, data retrieval is handled efficiently on the back end while the front end receives optimized responses. Currently, uh, driver has multiple redundant loops to manage different animal lists. MongoDB aggregation capabilities allow us to centralize these operations, providing filtered lists directly from the database. For example, using aggregation pipelines, we can retrieve lists of all available animals in one query, reducing application level data processing. This centralized retrieval is more efficient and easier to maintain. Consolidating repetitive loops with MongoDB aggregation framework minimizes code application or complexity and improves data handling efficiency. The backend can now manage data while the front end only receives the necessary information, simplifying the overall application. My enhancement plan includes replacing array lists with MongoDB collections, which will be accessed by API endpoints, creating backend methods to handle filtering tasks, allowing the front end to call specific endpoints for tasks like finding available animals, refactoring the code and driver to use efficient database queries instead of in-memory searches, optimizing methods like reserve animal and print animals with MongoDB aggregations for faster data processing. For databases in category 3, the current application stores all memory or all data in memory, resulting in data loss when the application is closed. MongoDB integration will allow us to persist data, making it accessible across sessions and ensuring durability. MongoDB collections for dogs and monkeys will store documents with attributes specific to each animal type. Frequently queried fields like name, training status, and reserve will be indexed, making retrieval faster. With MongoDB, CRUD operations can be managed via API routes in Animal Manager. For instance, adding a new animal will involve creating a document in MongoDB, and the backend will return response for the front end to update the user interface. For databases, my plan is designing collections with indexes for efficient data storage and retrieval, setting up backend API routes for CRUD operations, refactoring driver methods to work with MongoDB instead of in-memory lists, implementing robust error handling to ensure secure database connections and reliable data management. Thank you for joining me for this code review. I have covered the Rescue Animal app in 3 categories: software design, algorithms, and databases, with the plans to implement full stack architecture by making the application modular, efficient, and persistent. I aim to make it more scalable and user friendly. These improvements demonstrate my skills in software engineering, data management, and full stack development. I look forward to implementing these changes and sharing the results. Thank you.